So for my question, so I teach fifth and sixth grade math, and then sixth, seventh, and eighth grade science. So I have 5 different classes every day. For science, I feel like there's enough technology integration as it is, so I really wanted to focus on math. And so for my question, I wanted to do how do I make the concepts just more engaging and innovative. So at first, what I really wanted to focus on was kind of like reframing the way to like look at math to make it more interesting or more engaging or more fun. So what I really tried to do at first was kind of restructure the fourth quarter of math to make it like a, a baby econ class sort of thing. Talk about budgets and financing and supply and demand, like that kind of stuff, as much as you can at the sixth grade level. And then the more I thought about it, the more I realized that that was more interesting for me than it was for the kids. So I realized that I needed to kind of, again, reframe the way I looked at it. And I looked at what 2 chapters I have left for sixth grade math, and that is graphing and equations and probability. So I figured, why not just play games instead of quizzes and then give a test after that? So I started doing this experimental thing with graphing. So we're taking coordinate points, if it's 0, 2, putting it on the grid. So what we're doing now is, when I wanted to turn everything into a game, turn anything more fun, I decided to use existing games. So we've been playing Battleship a lot for the past week. So what happens is the kids have we use a 6x6 grid, and they get to place the battleships wherever they want. And depending on how we're doing on a given day, I can differentiate it or scaffold it. So we started off with just one ship, and it had to be in just one quadrant. They both had to be positive values. And then now by the end of yesterday, what we were able to do is you had 3 ships, and you could have them in any of the 4 quadrants. And so when you're guessing, you have to do 0, -2, and then you go on your grid, and then you just play Battleship. And so what we're doing next week is we're going to kind of graduate into slopes. So they're not going to have a ship, but they're going to have a slope, so x plus 2. And if the person you're playing against they correctly guess one of your coordinates, they have to then guess what the y equals equation is based on the points that you hit going up and up and up and up. So this was kind of just like me trying out to see if it would work, and it's been going great. So then I decided to expand it to probability. And so that's what this Poplet is. It's one of my favorite games. It's super, super complicated. It's a board game called Settlers of Catan. So what happened was, all of the green boxes are just vocab words or standards that I have. This is for me, by the way. This is not at all for the kids. This is just for the organization of my thoughts. The green boxes are all vocab or standards or things that I have to hit. Independent versus dependent events, experimental probability, outcomes events, combinations, things like that. And then the red boxes are all ways that the kids will actually do it, to see, like, could I actually check every box from the chapter through a board game? And because of how complex this board game is, I'm able to. So all of those things are potential questions that they could generate or they could answer. So the ThingLink, and you guys are actually my test case right now, because I haven't done this. So if I can explain this very complicated game through the ThingLink right now, I'm hoping it will work out. So, actually, let me pull it up myself. So the idea is, at the end of our probability unit, that they will make something basically identical to this. So the way this game works is you need certain resources to win. The light green ones are sheep, the dark green ones are wood, red ones are brick, yellow ones are wheat, did I say that? Silver ones are rock. So you need all sorts of different combinations of resources to win the game. But rather than play the game as it is, I just wanted to turn it into probability questions. So each number roll, each dice roll, or each number represents a dice roll. So let's take, for example, that red 6 in the middle. What that means is, if a 6 is rolled and you have a little house on one of the corners of those 6s, you get to pick up a wood. And as you accumulate resources over the course of the game, you have more chances to win. So if you go to the bottom three little icons I set up, they kind of explain what each of the pieces means. So if you go to and hover over the one that says road, roads are how you get from resource to resource. So like for example, the player right now has no access to brick. So they would need to build a few roads to get over to brick in order to collect it in order to win the game. And then if you go to the next one for the settlements, those are the little houses that you put on the corners. You can't pick up any of the cards. You can't pick up sheep or wood or brick or anything like that until you have a little house on one of the intersections. And then a city, that bottom one, if you have that guy, it doubles the number of cards that you can pick up. So if you look at the board, that house that's right above the number 6, what happens there is if an 11 is rolled, that house is on the corner of an 11, so I get to pick up a rock. If a 5 is rolled, I get to pick up a wood. And if a 6 is rolled, I get to pick up a wood. Are we semi okay right now? Okay, so then if you go to the top corner, these are the sample questions that the students would then generate themselves, and hopefully if you guys are understanding the core concept of the game, you can do. So if you go to the top right icon, it's how many wheat resource cards will this player pick up if a 9 is rolled? So they would pick up 3 because they have one of the big cities and one of the little houses, which would mean 3 wheat cards. So that would be kind of a sample to try and get them into the game. But then for a more probability-based question, if you go to those top 4 icons that I have, the top left of those top 4, it says, what is the likelihood that a player will pick up a sheep resource card on the next roll? So then what you need to do is say, okay, well, where do I have the possibility of getting sheep? If a 10 is rolled, I have the possibility, and if a 12 is rolled, I have the possibility. So then what the kids need to do is they need to start logging or start answering the questions as you go along. If a 10 is rolled, then you have a 3 out of 36 shot. If a 2 is rolled, that's a 1 out of 36 shot. So then what they have to do is add 3 out of 36 plus 1 out of 36 to get a 4 out of 36 shot. The next time you roll the dice, that you're going to pick up a sheep. And then you can get into things like simplifying fractions, especially with a number that's really easily divisible, like 36. So what I'm envisioning the kids doing is taking the game pieces and setting them up themselves, setting up and generating their own board, and then basically creating interactive worksheets. Is they'll exchange with each other, and so I will give my board to another student and have to answer the questions based on the icons that they have on their board. So like if you made a board, your numbers might be totally different places. And there might be a 4 or a 6 or a 7. They might be anywhere. So each kid will be able to generate their own unique board and then exchange it with other people. And then kind of the finale is generating a bar graph of like what would the expected probability rolls be versus what actually ended up happening. So the 3 pieces that they would be turning in are this interactive thing link with probability questions, and then the 2, what was expected to be rolled and how often it would be expected to be rolled, and then what actually ended up happening if you played the game and actually rolled the dice. So yeah, and then since I've been doing this, I've been thinking there's basically a board game to match up with every math topic. So next year, that's what I'm really going to try and integrate at the end of every chapter is a board game or I personally hate Monopoly, but something like a Monopoly or a Scrabble or a Battleship or something at the end of each chapter, at the end of each unit to show, that you can turn it into a game. You can make it more fun or interactive. And then the technology aspect, you can throw things in like a thing link and make each board or each game different.
Are there directions on what you just offered?
Yeah.
There are all these directions are on here.
I could have made it much more complex. So like if you hover, if you hover over that little 11 on the thing link, What I included there is like, if you rolled the dice, there are 36 different possibilities that can happen. It's the 11 at the bottom. If you hover over that, so this is the other thing that I would want kids to do, is to link graphs into the icon, so that if there are 36 different possibilities, a 7 is the most likely thing that's going to be rolled, and that's going to show up in that graph. So again, this isn't necessarily the goal of the game itself, but you can morph it into whatever you want it to be. So I'm focusing on just the probability aspect of this game. If I wanted to expand it, I could take, so all the game shapes are hexagons. And the great thing is they're not connected, they're not glued together, so you can pick up those hexagons and move them wherever you want.
On this?
Not on this actual thing link, but on the actual game, on the actual board. So what I could do is, if I wanted to include this in geometry, I could say something like, these are all regular hexagons. And then I can say, how would the game look different if we use squares? How would the game look different if we use pentagons? How would the game look different? So to emphasize the idea, well, if we used octagons, there would be a lot more points of intersection for them to be able to get more access to things like that. And then in the broader game, you can trade resources. Like I said, this person doesn't have access to the red brick because they don't have a house built there. So if you had access to it, we could talk about short-term versus long-term games, supply and demand, because if no 4s are being rolled, then nobody is having, so you can tie in however much you want, but I tried to boil it down to just the dice rolling aspect of this game, what you can or can't pick up.
And what kind of time frame do you devote to this? Because this could be forever and you would still have their attention nonstop.
Right, so I would do it at the end of the chapter, and I would go through my thing link it would probably take me 25 minutes I'm envisioning a 3-day class time for this. Is probably a full day to explain and set up and get them oriented, and then 2 days to create digitally, and then the final hard part too. Right, and so that's the thing is, realistically, you could have done this for any dice rolling game. I just chose this game because I personally like it. But you can do it for Monopoly and say, what's the likelihood that you're going to land on a bad spot the next time you roll? You don't want to land on something where you're going to have to pay money. You don't want to have to land on something where, so you can literally make it that simple. Probability of bad outcome, probability of good. You don't have to necessarily make it this complicated. So you can pick whatever game you want to. And I really like Thing Link because the kids can generate their icons. So you can leave the number spaces blank, and you could put an icon there instead of the number and ask something like, if this was an 8, how likely would it be that you would pick this thing up? So that sort of thing. So.
Good.
Yeah.
Very good.